Welcome back. And now we're going to do a third problem, okay, multiple answer problem, and where our goal is to find the solution to all the intervals. And once again, a little bit more difficult than the previous two problems we've done, not as basic, but what we have right here is we have cosine of 4x times the quantity cosine of x minus 1 equaling 0. Now, what you notice is that cosine of 4x is multiplied by this expression cosine of x minus 1, and yes, they equal 0. So just like in algebra, if we had like x times y equaling 0, in order to solve for this solution, we would say, oh yeah, it's when x equals 0, and then when y equals 0, we set each one of these equal to 0, and we know that x is going to equal 0 and 0. So without further ado, in order to solve this, we're going to take each one of these individually. We're going to take cosine of 4x. We're going to set that equal to 0. And then on this side, we're going to take cosine of x minus 1 and set that equal to 0. Well, I'm going to go through and do the simple one first because I take the simple one, and the simple one I'm referring to is the one that does not have a b value of something other than 1. So right here, we notice that our b value is 1. And here we see our b value is equal to 4. This one, we know we're going to have multiple solutions. Okay, we're going to have to use coterminal and other things like that. Coterminal. Okay, coterminal. And this one is just going to be standard. So without further ado, let's figure out this one first. Now remember, looking at the problem, we're trying to find all solutions from 0 to 2 pi. So the first step is solve for the trig function. So we're going to solve this one. We're going to get cosine of x. We're going to add 1 to the other side, so cosine of x equals 1. We can graph this, and we know cosine of x equals 1 from 0 to 2 pi, and that's going to be 1, well, right here at 0, because it's going to be 1, 0, cosine x sine y. Over here, it's negative 1, and we're not looking for the negative 1 answer. And right here, it's 0 at 90 degrees, 0, 1 on the unit circle. And then down here, it's going to be 0, negative 1 on the unit circle. And so that's why we have right here 1, 0. So our solution, when we solve this, x, when we take the inverse of 1, x is going to equal 0. It would also equal 2 pi, but because this is an open interval, it's not equal to. So we don't have to include that. So here is going to be one solution to this problem that works out perfectly and symmetrically. All right, next one is now we're going to solve for this puppy right here, cosine of 4x equaling 0. First off, solve for the trig function. Boom, done. There's nothing new to do here. We can graph this. We're going to graph this maybe optional later, just to verify all our answers. And then we're going to solve it by using our trig inverses. And so I'm going to take the inverse cosine of both sides, and that's what we get right there. When we have this, we're going to solve for this right here. Cosine of 0, well, cosine of 0 is the x. That's going to be here and here. So we know our answer is going to be 4x is going to equal pi over 2. And also, 4x is going to equal pi over, or 3 pi over 2. Now, once again, because this is a b values other than 1, I know I'm going to have more solutions. So if you saw my other video, we're going to add plus 2 pi n here, plus 2 pi n here to get all of our additional values. So now the next thing we're going to do is right here. We're now going to solve for our variable. We're going to solve for x. So for both of these, I'm going to put a little here. When we solve for x, we're going to multiply both sides by 1/4. 1/4 to get rid of that. Here, we're going to multiply by 1/4. 1/4. And what we have then is x is going to equal pi over 2. This is the first one right there. Plus, well, 1/4 or 2 pi n over 4. And then I'll put right here, x is going to equal 3 pi over 2, okay, plus 2 pi n over 4, right there. Okay, well, this can be simplified pretty nicely. This and this can cancel out, turn to 2. This and this can cancel out, turn to 2, which help us out Because we know we now have pi over 2 plus pi over 2n. Same thing over here, 3 pi over 2 plus pi over 2n. And what we can do is we're going to take this value and we're going to just keep on adding values until we get to, remember, stop at 2 pi. All right, and so that's going to equal 4 pi over 2. How do I get that? Because I'm looking at the denominator there to help me figure out what the value I'm going to stop at is going to be. Okay, so we know that one of our answers is going to be 0. Okay, now our next answer is, well, now let's figure out our second solutions. Well, we're going to start out here. Start with this one. When n equals 0, we know our value is going to be pi over 2. So that will work out. That works out just smashingly. Okay, pi over 2. Okay, so cosine of pi over 2. Yep, okay. And we have cosine of pi over 2. Cosine of pi over 2 is going to be cosine of 2 pi. Cosine of pi over 2 is going to be 0. Hang on one second. Let me just check this out. All right, we're just... Yes, you may have noticed that I did screw up. I hope that you figured this all out beforehand, because right here I just found out that this didn't make any sense whatsoever while we're going through here, because that does not help us out. So, so what we forgot to do, if you already figured this out, is when we did this right here, this is not going to equal 2 anymore, because we have to distribute this to here and to here, here and to here. I apologize. This actually has to equal 8. Oh my goodness, I feel so embarrassed. And this is going to equal 8 as well. And so now what we have is 2 pi over, that's not going to cancel out. I'm going to get rid of that. And get rid of that. And so what we're going to do here is we're going to get rid of this. And we're going to simplify this and just cancel this out and make this a little bit better. Oh my goodness, I'm so embarrassed. When we have this, we're going to have pi over 8. Okay, and right here I need a 2 because I need a common denominator. So it's going to be 8. And then we're going to plus, I'm going to just make this 8 right away. So I'm going to make it 2. So we have 4 pi n over 8. And over here, same thing. We have 3 pi over 8 plus 4 pi n over 8. And what we need to do is we need to stop at 2 pi, which in this case is going to be, all right, if we have 8s in there, it's going to be 16 pi over 8. So same thing now, when n equals 0, one of our answers is going to be pi over 8. And I'm going to make this go down. And now we're going to find the remaining values. So now what happens when n equals 1? When n equals 1, we have pi over 8. We're going to have plus 4 pi over 8, which is going to equal 5 pi over 8. Next one, when we keep on going down, what happens when n equals 2 in this case? When n equals 2 in this case, we're going to have x equaling pi over 8. And then we're going to have 2 times 4, which is 8, 8 pi over 8, which is going to equal 9 pi over 8. You probably can start seeing a little pattern as you start doing this a little bit more. All right, 3, we'll have x pi over 8. We're going to have up here, when we have this right here, 3 times 2, or 3 times 4, which is 12. So we're going to have 12 pi's over 8, which is then going to give us 13 pi over 8. How far do we have to go? We're going to 16. I'm guessing we're probably going to stop here. We'll try one more time. N equals 4. If x equals pi over 8 plus, take 4 times 4, which is 16. Well, that's not going to work out. 16 pi over 8. We already passed where we need to go, so we're not going to go any farther here. So this one's going to cancel out, and so we're left with this. We then go to the next side. And where's my cursor? There it is. All right. And we need to stop right here. And hopefully you can read that. Stop. All right, and so now when we have n equaling 0, we know we're going to have 3 pi over 8. So we want pi over 8, 3 pi over 8, 5 pi over 8. I'm guessing the next one's going to be 7 pi over 8. Just to make sure, we add 1 right there, 3 pi over 8, plus it's going to be 4 pi over 8. Yep, 7 pi over 8. And you can see a pattern is forming throughout the thing. So if you notice that pattern, you don't have to keep on going through every single time. It's going to be 7 pi, 9 pi. The next one's going to be 11 pi. How do we get that? 3 pi over 8. Plus, now we're adding 2, so it'll be 8 pi over 8, which would be then equal 11 pi's over 8. 11, 13, and the last one obviously is going to be 15. So when n equals 3, we have x equaling 3 pi over 8 plus 12 pi over 8, which is going to give us 15 pi's over 8. And that, my friends, is just where we're going to stop. And so we have all of these as our solutions. We have one here. We have one there. We have one there. One right there. Another one right here. And there. There. And here. And that was all the values. We have 8 possible solutions for cosine of 4x. And in this one, we have one solution, which is just 0. And we can verify that on our calculator. So if you want to take a moment, put this into your calculator, or I can pause this, and then I'll be back 1 second just to show you about that. And I'm back. So if you took out your calculator, you should have put this in here, our equation, which is right there. I put 0 in for y2. And so now what we can do is we can look at our window. Once again, we're from 0 to 2 pi. I went pi over 12. Don't need to go this big, but did it anyway, and then you can graph it. This is the graph that's going on here. And if you see here where this is hitting, it's hitting here at 0, 1 here at pi over 8, next one here, and you can see every single one of the values where it hits. So if you see 1, 2, 3, 4, 5, 6, 7, 8, and 9 right there, we have our solution. And obviously it goes up to 2 pi, but that's what we have there. So you can see all the various solutions, and you can check those by tracing, but you can verify that on your calculator as well. Okay, so here's another example of how to solve an equation with multiple solutions, and hopefully it serves you well. I apologize for screwing up. Got to be careful with your algebra. Make sure you distribute that through properly, or you can get a wrong answer. All right, so with that, yeah, I'm going to have one more problem dealing with this in the next coming slides, so good luck and God bless on the rest of your problems.